So subharmonic functions. A function u defined from an open set omega is said to be subharmonic. It's subharmonic. It has following properties. First, it is a real valued function. Its value can be minus infinity, but it can be infinity for all that belongs to. Second, u is upper semi-continuous. Upper semi-continuous. It means u inverse minus infinity to y. H upon in omega for all y belongs to. So this is the second property. Is it clear?
Yeah, continue.
Screen share हो ना?
Everything is fine.
Okay. So use upper semi-continuous and see next property. Whenever the closed is in omega, then u is less than equal to 1 by 2 pi minus pi 2 u a plus r. So we can see that if u is harmonic function, then it satisfies the mean value property, which is u a equal to 1 by 2 pi minus pi to pi u a plus r. It u is harmonic. It satisfies this property, which is called mean value property. But subharmonic function, for subharmonic function, u is less than equal to 1 by 2 pi minus pi to pi integration minus pi to u. This we can say that this property is sub mean value property. the value at A is always less than equal to X. Okay, and this if it's closed X, then this integral it's never minus infinity. So this integral it's never minus infinity. This is the property D. So this is sub mean value property. U must satisfy sub mean value property. U is upper semi-continuous and U is real value. It can take any value except infinity. Now, we'll see a property of this subharmonic function. That is our theorem 17.2. If U is subharmonic, in omega, then and if phi is monotonically increasing, convex function, and Chandan, can I ask you a question? What is R1?
Yeah, what is the question?
What is this R1 actually?
R1 means
It
our real
includes infinity. What?
or extended R. You can say that the extended R.
Extended. Okay, okay. So phi is a monotonically increasing convex function on extended R. Then higher composed U is so. Okay, so group. So phi is monotonically increasing and continuous because phi is increasing and continuous. And U is upper semi-continuous. So phi comparison of U, it's
Why
upper semi-continuous.
Wi-Fi is continuous? Because phi is given monotonically increasing and convex function.
Phi is convex function.
Then we can say that it is continuous. I mean, does this imply it is continuous?
I don't know actually.
I think yeah, I can use. I mean, we can use that monotonically increasing with convex to show that the function is continuous. I think, yeah, you can go. Go ahead. Yeah, continue, Kana, continue.
Okay.
Just check the inverse image. That will be exactly that form.
Actually, I could not do this. How this is upper semi-continuous. So
Can I just take inverse image? Inverse image of those type of set to that to close minus infinity close and open something A or Y.
and if this closed is subset of and first phi UA is less than equal to phi 1 by 2 pi minus pi pi U U A plus R sin theta. Because U is subharmonic, it is given, and subharmonic, so it satisfies this property. And phi is monotonically increasing, so phi U is less than equal to phi this. Okay. Then we can refer to theorem 3.33. Would say that d mu is less than equal to where mu is a positive measure. Positive measure. And
Mu
measure
is
of omega
positive. Probability measure.
mu
Yes,
is
yes,
positive measure.
yes. It is. It will be probability measure. I mean, this is measure of
That is a real
mathematics.
function. That is a real function, and phi is convex. If fx greater than a less than b, and if phi is convex, this interval area, then this holds. So from this, if you apply this theorem theoretically to this, then where this is less than equal to 1 by 2 pi minus pi square have f plus r. So phi of u at a is less than equal to this. So phi of u, this satisfies sub-mean value property.
Can you explain that why 1 over 2 pi came outside of this integration?
What?
Is it 1 over 2 pi? Scalar.
1 by 2 pi.
Here it is the, I think it is the use of this probability measure, because d theta by 2 pi will be the measure, will be 1. Entire measure is, what is the area, what is the perimeter of the
Measure
circle?
is
2 pi, huh?
1 by
Hello?
2 pi is included in this measure.
हाँ, उसका measure 1 होगा, हाँ. That's why 1 over 2 pi came outside of this. Okay, okay. Go
Measure
ahead.
of
Huh?
so so this is upper semi-continuous. This is the sub-mean value property. So this is sub-harmonic. Now we will apply this theorem. To see that if this is a region, omega is region, and F is holomorphic in omega, and F is not identical G. Then log of mod F, log of mod F is subharmonic, and log mod F to the power P, where P is greater than 0, less than infinity. These two functions are also solved. So subharmonicity of this function mod F to the power P, this helps in defining the Hardy spaces, HP spaces. That is why we are studying subharmonic function, starting from subharmonic function. So we define we say that log this is minus infinity. If fz equal to 0, then we say that log mod fz equal to minus infinity. And log mod f is upper semi-continuous. How log mod f will be upper semi-continuous? Chandan, can you explain? I could not do actually.
You can take with the by usual definition, I think. Even it is not only subharmonic, it is going to be harmonic. So since it is harmonic, it is automatically going to be harmonic.
This will be harmonic.
Since it is every harmonic function is subharmonic, right?
No,
Yes or
no,
no?
at
Every
zero,
harmonic
why it is zero, there will be problem actually.
Only
At
that point you have to check. That only the submeaning You have to check the submeaning at z equal to 0. I mean fz equal to 0.
not submanifold is upper semi-continuity.
Submeaning will directly come because it will be minus infinity. So minus infinity. Only the upper semi-continuity. But why you are going to do this in this way? Since we have this function as a harmonic function. So it is automatically for any non-vanishing harmonic function. We know that log of mod is basically a harmonic function.
It
You can
can
take
be,
a
but it can vanish. Na, it is not identically zero, but can be zero at some point.
that I'm not saying that identically 0. I'm saying that it's not vanishing at any point.
At what at?
So you are saying if fz equal to 0 at some point or fz equal to identically 0?
FZ,
fz is not identical.
fz can be 0 at some point, and
हाँ
at that point we have to check upper semi-continuity.
yeah. You can take the interval actually by definition, minus infinity comma alpha. Do you know?
Directly by definition.
Do you know there are, I mean, several definition of upper semi-continuous apart from this open interval minus infinity comma alpha. Huh?
Uh,
I mean, there
definition
are
why
what?
I greater than f at 0, then there exists a neighborhood. There exists neighborhood u
Huh.
for which f less than.
Can just use the definition, right, of upper semi-continuity?
You can use the definition actually.
That closed interval minus infinity. No, closed infinity open A. If we are taking, then we will get an open set every time, right?
Yeah, Kana, right? That
Which definition?
just use the any for let alpha greater than 0 and just start the definition by using that let. First assume that u equal to log of mod mod fz uz equal to log of mod fz. Okay. And let alpha greater than 0. Then take u inverse of minus infinity comma alpha close minus infinity comma उसका definition इसका क्या what is the meaning of this actually?
Yeah.
Log of mod f z is lying between minus infinity comma alpha. Those z इसका definition लिखो equal to z second bracket set के फॉर्म में लिखो ना, right? Equal to हाँ equal to this is equal to, yes, this is equal to z such that minus infinity less than equal to log of mod of z less than alpha, minus infinity less than equal to
log of mod less than alpha.
और लेफ्ट साइड में माइन हाँ ओके ओके क्या बोल सकते हैं इसमें सिंस लॉग इज इंक्रीजिंग ट्राई log is increasing and say okay exponential function increasing, take first write that left hand side is also minus infinity, left hand side is also minus infinity. अरे z such that उसके बाद हाँ लॉग के पहले उधर माइनस इंफिनिटी लेस देन इक्वल टू होगा ना. हाँ अभी देखो z such that this condition hold and we all know that e power exponential function increasing in a real sense, so take exponential, so order will be maintained, right? So 0 less than equal to mod fz less than alpha.
Okay. This is mod fz
less than e power alpha. 0 less than equal to
greater than
less than e power alpha. Then क्या बोल सकते हो? So fz will lying inside this disc e power alpha, radius of e power alpha, right?
Yeah.
Left hand side जो लिखा हुआ है ना 0 less greater than equal to 0 less than equal to fz, it is obvious, right? So no need to write 0 less than equal to fz. No need to write 0 less than equal to fz. Just erase this fact because we know that 0
so this
mod fz.
This is the open disc.
Why it is open disc?
No. Sorry.
Because f is holomorphic, na? F is holomorphic, right? Then and what you can say from here? Mod f is lying between these discs. Okay, yeah. Mod fz is lying between the disc center at 0 with radius e power alpha.
Yeah.
तुम सोचो, तुम अपने से सोचो. Think about yourself. ball center at 0 with radius e power alpha. And since fz is a holomorphic function, so it must be an open mapping. I mean open map.
Yeah, that is holomorphic. So
So it must be an open map. You know that open mapping theorem that if a non-constant holomorphic function
yes,
is maps and so what we can say, this jet, if we take in a think about yourself, if we take jet around,
yeah,
around jet, if you take a ball, image is also going to be, image is also going to be ball centered at fz.
yes. So this is this we can say this is F inverse
Uh-huh.
this.
Uh,
And this is 1.
it will be mod F inverse, I guess. F inverse or okay, sorry. Yes, F inverse. Okay. Yes, F inverse. Yes. Yeah. Then it's done. हाँ हो गया अभी तो हो गया या कंटिन्यू करना हो गया
It's easy to prove complement is closed.
So this is proper semi-continuous, and
No, I'm saying it
by
is easy to
theorem
prove
by theorem
complement
of
is closed.
harmonic function, chapter harmonic function, given
what you Nishad say
19. Hmm?
I'm
what you are
saying
saying हाँ
it is easy to prove complement is closed.
okay complement is closed.
Actually, we can rub that alpha greater than 0, right?
Or otherwise, we can use another definition, another version of definition of upper semiconductor.
No, he is not using any another version, just he's using the usual
Then,
definition.
then try to prove complement is closed.
Okay, who is trying to prove that complement is closed? This is the definition. Minus negative one alpha. Huh? Yeah, Kana, go ahead.
Actually, no.
So
We can rub that alpha greater than 0, right?
अच्छा yes खाना हाँ वो तो आर्बिटरी होगा ना अल्फा ग्रेटर देन 0 क्यों होगा खाना that alpha may be any arbitrary number
yeah, alpha may be negative also.
हाँ sorry
But for alpha greater than 0 it is true. So we can
See, Kana,
yes.
write down. I'm saying write down like le- uh, uh, try to prove that set log mod f of z greater equal to alpha. This set is closed. Right.
yes
Write it down. Log
हम्म पहले लिखो let alpha belongs to right alpha
right
belongs to
चलो
R
उसका फॉर्मूला
Alpha belongs to R.
हाँ let alpha belongs to R
then
देखो
set
set Z such
that
that
belongs to that domain. What is the domain? Domain
Z
was
देखो काना ब्रैकेट दो सेकंड ब्रैकेट लिखो
What?
सेकंड ब्रैकेट स्टार्ट करो हाँ Z देखो निशित बोल रहा है
Okay.
निशित
log
बोलो
mod f of z log
Log
mod f of z get equal to
okay.
alpha.
Less than alpha.
ग्रेटर अल्फा ग्रेटर इक्वल जो उसका कॉम्प्लीमेंट देखा है ना वो देखो वो बोल रहा है वो तुम जो पहले कर रहे हो ना उसका ओपन हाँ exactly.
This is our claim. This set is closed. Why this is closed? Because take Zn array sequence which is converging to Z0. Assume Zn belongs to this set and Zn converging to Z0. Right?
Zn wn बोलो wn
Okay,
Zn okay
W.
Zn
What?
দেখো
take
একটা
Zn,
x, what is the definition of sequential definition of closeness বলো কানা? If we choose any arbitrary sequence, बोलो.
that will converge to a
No, पहले convergent
convergence.
sequence उठाना पड़ेगा. Zn converges to Z उठाना पड़ेगा और Zn converges to Z नॉट उठाना पड़ेगा. उसका इमेज उस साइड में होगा, मतलब Z नॉट उस साइड में होगा. Zn सीक्वेंस उससे उठाएंगे आप. I mean, we will assume Zn from this set and which is converges to Z naught. Z naught is in C. तुम्हारा C नहीं, ओमेगा. Okay. And मुझे दिखाना है वो Z naught इस सेट में.
Z naught belongs to this set.
हाँ हाँ. वो अब अभी का वो निश्चित बोलो.
हाँ लिखो Zn belongs to this set. So Zn belongs to this set and Zn converging to Z0.
Okay.
Okay, now we have to show Z0 belongs to this set.
Okay.
That means log mod f of Z0 get equal to alpha.
Yeah.
So if not, then log mod f of z Z0 less than alpha.
Yeah.
Okay, less than alpha.
Yeah.
Now if Z0 as such point such that log mod f of 0 is not equal to minus infinity, at those point it automatically it's always continuous. That is not the problem.
Yeah. Since you are assuming Zn, so log of mod of fZn is greater than equal to alpha, right?
Yeah.
Get equal to alpha. No, I'm saying now we have to show this will we will get from there a contradiction. So contradiction.
राइट खाना राइट नहीं तुम तो समझ नहीं आएगा तुम. लिखो तुम.
लिखो. Right?
बताओ.
If log mod f of Z0 not equal to minus infinity,
Not equal to minus infinity.
then at Z0 this is at Z0, then at Z0 log mod f of z always continuous or no, just continuous. Okay, not always continuous at Z0. This is clear.
This is not equal to minus infinity. Means
If
f0 not equal to 0.
if not minus infinity, then at Z0 log mod f of z is continuous. This is okay.
Okay.
Because we know if where it's not 0, it's at those point it always harmonic, not only subharmonic, it's harmonic. Okay, using those thing, that thing, that where it's not 0, there not minus infinity, there it's harmonic.
This is harmonic.
Ah,
Okay. If not f0 is not 0, then
basically f of z0 is not 0.
okay.
Now if log mod f of 0 equal to minus infinity,
If this is minus infinity, then
okay, if this is minus infinity, okay, now since alpha is a real number,
yeah.
now since alpha is a real number, we definitely will get a open ball or neighborhood of z0 such that their log mod f of z0 is less than alpha.
What,
Okay, first write it down. See, since alpha is real number,
since alpha is
then there is a neighborhood of alpha or like there is a neighborhood of alpha or there is a neighborhood alpha, let's say n alpha, where log mod f of z less than alpha,
where log mod f of z
less than alpha for all
less than
z belongs to n alpha. Now say this is clear or not. Now tell me this is clear or not? Clear or not? Since f of z0 is log mod f of z0 is minus infinity and alpha is a finite real number. I mean any real number just.
alpha is a finite real number, so
I mean, we don't need to
okay,
do
okay.
these things actually.
Uh-huh.
Directly we can say, see, go, Kana, scroll करो ऊपर
Just
उठा.
continuity.
हाँ?
Where continuity of log mod f?
उसको ऊपर स्क्रॉल करो, थोड़ा स्क्रॉल करो, ऊपर ऊपर ऊपर.
And now this
What
is the basically contradiction actually.
what you have actually, Zn it's taken from this set, right? So we can write log of mod of f of Zn is greater than equal to alpha. Okay,
Yeah.
okay. And since f is your holomorphic function, it may be zero at some point. So log, the domain for log is here actually close 0 to infinity, right?
Yes.
Here, log of mod of fz. So, I mean, the domain for log is basically close 0 to infinity. See, think about the log function. Log is what? Log is continuous in open 0 to infinity. And we can extend
Mm.
at 0. By putting at 0, it is infinity, minus infinity. 0 में इसका
Yeah.
इंफिनिटी मतलब उसको एक्सटेंड कर सकते हैं, लॉग को एक्सटेंड कर सकते हैं थ्रू आउट क्लोज 0 टू ओपन इंफिनिटी, है ना? तो क्या है
Yes.
मेरे पास, व्हाट यू हैव एक्चुअली लॉग ऑफ मॉड ऑफ एफ ऑफ जेड एन इज ग्रेटर देन इक्वल टू अल्फा. नाउ टेक द लिमिट, log is continuous, f is continuous, take the limit, so log of mod of f of z is greater than equal to alpha. Directly you say from there. Okay,
Okay.
वन लाइन में हो जाएगा इतना कुछ, थोड़ा देखो तीन से ठीक है. हेलो,
হ্যাঁ বলো বলো
I mean since log is continuous in open 0 infinity, okay,
হ্যাঁ হ্যাঁ
so we can extend it to close 0 open infinity by taking at 0 minus infinity value, right?
as I mean basically same concept. I mean actually I'm writing it down. I'm explicitly
Contra
thinking
positively, contra positively, yes, yes, that is what I'm doing. Okay, it's fine, Kana, go ahead, next, go to the next one.
Okay. So
It will be better if we next time we will do it offline basically. Then it will be fine.
okay, we will do it offline.
Hmm. Okay, okay, go ahead.
So theorem 15.19 from chapter harmonic function. From chapter 0 of holomorphic function. This is this also I actually could not understand how this theorem, from this theorem it follows that minus pi to pi.
Hmm.
Actually, theorem 15.19 is telling about this mu rf, which is 1 by 2 pi minus pi to pi log fr. I could not understand how from this will follow.
Yeah, here you can define like URF. Instead of mu, there it is defined mu RF, right? So you can define URF. URF is basically integration over 1 over 2 pi log of mod of a plus AR. It will directly come from there. It is a non-tangential Maxwell function of mu. Actually, it is basically the extension value of, extension limit of log function. Kanha?
Okay.
It is fine. It's fine. So we can do it later.
Okay. So this log mod f is subharmonic. And if we take this is a convex, monotonically increasing convex function on R1. Monotonically increasing. Convex function. So phi of f equal to log mod f. Maximum of 0. This is defined at log plus. So this is subharmonic. U is subharmonic. So by the previous theorem, phi of u, that is log plus mod f, this is also subharmonic. Similarly, if we take for p belongs to 0 to infinity, e to the power pt, this is also monotonically increasing convex.
शेवर बहुत बड़े काम करता है उसे भाई दाढ़ी मूछ तो ये दिखा ही लेता है और ये खुलता है उसे भाई इसके अंदर पंखा होता है इसके साथ आप अंडा भी देख सकते हैं और अंडे भी साफ कर सकते हैं अंडे मिक्स करके जूस बना देगा भाई ये छोटा सा शेवर चले जी ये मंगवाते हैं और इसका कमाल की चीज है भैया छोटा पैकेट और
log mod f.
काम से लेके आया भाई इतनी पावर देखते हैं ये सच है या
Not f z
इसका ये उतार लेते हैं उसे भाई मैं सबसे पहले बेटा इसके साथ खेलना चाहूंगा फिर बॉल साहब उसे भाई गिलास
or mod f to the power p z. So this function is our phi of u. So this is phi of u. And by the previous theorem, because u is subharmonic, so this is also subharmonic. So mod f to the power p, this function is subharmonic. If f is holomorphic in omega, then this is subharmonic. In omega. Okay. So yes. So next theorem. So here is we saw it log mod f. This is subharmonic and log plus mod f and mod f to the power p for p belongs to 0 to infinity are subharmonic. This is an important property for subharmonic function. So if u is subharmonic, continuous harmonic functions in omega. K is a compact subset of K compact subset of omega. H is continuous real function on K, which is harmonic and in the harmonic in V, which interior of K and usually less than equal to Hz at all boundary points of K. So this is sigma, omega, and K is compact. K is compact, and V is the interior of K. So usually is subharmonic in omega, and Hz is continuous on K, and it's harmonic in interior. And this U and H is a relation on the boundary of B or boundary of K. On the boundary of K, we can write for all Z belong to del K. This value of U is less than equal to value of H, and for all Z belongs to boundary of K. If these conditions are satisfied, then U is subharmonic, H is harmonic, and V continuous on K, then Uz less than equal to Hz for all Z belongs to. So this is the theorem. If Uz is less than equal to Hz on boundary, then Uz is less than equal to Hz for all Z belongs to. So let U1 equal to minus H. Suppose this is not true. Suppose usually is not less than equal to H for all z belongs to K. Then for some z, usually greater than equal to H, usually greater than H for some z belongs to B, because on the in the boundary it is already given that usually less than equal to H. So for some z belongs to B, usually greater than H, that is we can see U1 z equal to U minus H is greater than 0 for some z belongs to B. Now U is continuous, H is continuous, so U1 is continuous. U1 is continuous and K is compact. K is compact. So U1 attains its maximum M on K. So continuous function attain its maximum on K. Also in the boundary of K, uz is less than equal to hz. So u1z equal to u minus hz. It's less than equal to 0 on boundary of K. So this maximum must be greater than 0 because we have assumed at some z belongs to B, this C1z is greater than 0. So this maximum must be greater than 0. And this maximum, the point of maximum can be on the boundary because for all z belongs to del K, E1z is less than equal to 0. Okay. So let this set E equal to z belongs to K, E1z equal to M. So this set is closed subset of K. So this is non-empty because E1 attains its maximum in K. This is non-empty and compact. Now suppose Z0 is boundary point of A. Suppose Z0 belongs to boundary of E. Then okay, this is E is non-empty and compact subset of V, because E does not contain any point of del K. So E is entirely contained in V. So suppose Z0 is boundary point of E, then as B is open, B is interior of K, so it is open. So we have an closed disk. So we have for R greater than 0. Subset of B. Okay. We have this closed disk inside V, and at Z0 is on the boundary. So this is omega K V E Z0. This is the closed disk. So we have an arc of this circle of radius R and center Z0. So some sabak of boundary of this disk is in the complement of okay. So now we have A1 Z0 equal to M, because Z0 is a point of E. So A1 Z0 equal to we have M, and 1 by 2 pi minus pi 2 pi. And so suppose the sabak which is in E complement is gamma, and which is inside E, that is gamma. Plus gamma A1 z0 plus. So for all the point of this gamma, this value is strictly less than m, and here it is less than equal to m for all the point of so here this arc gamma has the radian this is less than equal to m into suppose and this is less than suppose this is a radian theta and this is 2 pi minus theta. So their sum will be less than m2 pi. ठीक जा रहा हूँ क्या चंदन?
हाँ हाँ पूरा ठीक है चलो अभी उसको कॉन्ट्रडिक्शन आ जाएगा
हाँ. So this sum will be less than m2 pi, which is m. So we have this m is we can write so this integration strictly less than m and m is e1 z0. So we have here e1 z0 which is m is greater than 1 by 2 pi minus pi to pi e1 z0 plus r over theta d theta. But e1 equal to u minus h. As you know, u is subharmonic and h is harmonic. So we'll see that u e1 z0 e1 z0 equal to u z0 minus h z0. U z0 is less than equal to 1 by 2 pi u z0 plus r e to the power I theta d theta, and by midwell property h z0 this equal to 1 by 2 pi by mean value property of harmonic function. This h z0 is equal to 1 by 2 pi h z0 plus r e to the power I theta theta. So this is 1 by 2 pi minus pi to pi u minus h z0 plus r e to the power I theta d theta. So this is 1 by 2 pi minus pi to pi e1 z0 plus r e to the power I theta d theta. So by the subharmonic property and harmonic property, subharmonic property of U and harmonic property of, where U1 Z0 should be less than equal to this. But so U1 is subharmonic actually. By property of U and harmonic property of H, U1 is subharmonic. But at this Z0, we have a contradiction to subharmonicity of U1. This is a contradiction. So our assumption that at some point U1 Z greater than 0 is wrong. It's wrong, and hence U1 Z or UZ minus HZ must be less than equal to 0 for all Z belongs to K. That is UZ minus HZ less than UZ less than equal to HZ for all Z belongs to. So if this inequality occurs on the boundary, then this inequality occurs on the whole set. So this is the proof. इतना ही रहने दें क्या?
हाँ ना ठीक है चलिए।
हाँ, it's fine, fine.
Okay, thank you.